Hello everybody, I hope you all are doing well and we are back with another banger. Another banger. Calm down. What am I even on about? But we are solving more MCQ questions and obviously I'm doing my bit and you guys should be doing your bit. So you guys should be practicing, you guys should be persevering, you guys should be working hard day in and day out. Not going crazy, not losing your sanity obviously, but you guys should be revising your concepts and putting in the effort that is needed because this MCQ paper will either make you or break you. It's the final paper to seal the deal. So you can either secure your A star or A, or you can just let it go, let it slide and be like, hey, my theory paper went well and ATP went well, so I'm not going to care about this. Please do not make this mistake, right? So without further ado, let's look into these questions, okay? So it says which sample does not contain a number of atoms. See, he's talking about atoms equal to the Avogadro's constant. Now there are multiple ways to go about it. You know, if you're good at mathematics, you would straight off the bat realize that D is the correct option just by even looking at all the options. But I'm gonna keep it simple for those of you who are not that good in moles, right? So you could have two ways about it. What you could do is, you know that Avogadro's constant is 6.02 into 10 is power 23, right? And you know that this number is effectively equal to how many moles? That's effectively equal to 1 mole. So if we calculate the moles of atoms, remember, once you use the formula here, you're going to end up with the moles of N2. But you need the moles of atoms. You need the moles of N, not of N2. So you would, in the end, times it by 2. And if it's equal to 1 mole, then we would know that it has these many particles in it, which would not be our option. We have to select an option in which you don't get 1 mole, and that would actually mean that it does not have these many particles, right? So let's do it. So 14 grams of nitrogen. We know that in 1 mole of nitrogen, I'm not using the formulas. You could use the formula mass equals mole times mr. I'm just using concepts, right? So we know that 1 mole of nitrogen has how many grams? 28 grams. So how do you know it has 28 grams? Well, pretty easy. We know that nitrogen in the periodic table is 14, but if you have 2 nitrogens, then obviously it should be 14 times 2, which would be equal to 28, right? 2 nitrogens would mean 14 plus 14, which is 28. Huh? So if 1 mole of nitrogen has 28 grams, 14 grams of nitrogen would mean how many moles? N cross multiply, what do you get? 0.5. But remember, 0.5 moles are of N2. We need to talk about the atoms. This N2 is a molecule. So what do? I further multiply this 0.5 with 2. Why do I multiply it with 2? Well, if I multiply 0.5 with 2, I'm going to get the moles of N, right? Because I know in one N2 you have 2 N's, right? You could also do it like this. If you're very weak in mathematics, you could say, hey, 1 mole of N2 has 2 moles of N. So if you have 0.5 moles of N2, how many moles of N would you have? Cross multiply. So again, it's same, 0.5 times 2, right? So this equals to 1, and therefore this should be eliminated. Done? 6 grams of water. Now I'm going to go fast. I explained the concept. Now let's go fast, right? So 6 grams of water. Well, we know 1 mole of water has how many grams? 18 grams in it. So if you have 6 grams of water, how many moles would you have? N cross multiply. What do we get? 6 over 18. That gives me 0.33333, right? And what will we multiply it by? What will we multiply this by? Well, these are the moles of H2O. We need the moles of atoms. How many moles, how many total atoms are there? 2 plus 1. You have 3 atoms, right? So what are we going to do? We're going to say, hey, 0.333 times it by 3. And what do we get? We roughly get 1. Yes, we get 1. So that is also going to be eliminated. Similar is the case with C. I'm going to move up a little. So 4 grams of helium, right? So we know that 1 mole of helium has how many grams? 1 mole of helium has 4 grams. So if you have 4 grams of helium, that would mean how many moles do you have? Obviously 1 mole, right? This is from the periodic table. Or you could use your formula mass equal mole times mr, which is a wrong formula, but hey, mass is what? 4 grams, moles you need to calculate, mr of helium is 4, n equals 1. You could do either or whatever you like. So again, C is also 1 mole, which would mean it has these many atoms in it, right? Helium is in its elemental state, so it's going to have, it's monoatomic, right? It is going to have all atoms. These were molecules. You have to convert it into moles, into the moles of atoms in the end, right? And 28 grams of carbon monoxide, obviously D should be my answer, like I predicted. But if you want to calculate it, you could do so. So we know that 1 mole of carbon monoxide would have how many grams? Carbon is 12, oxygen is 16. So 12 plus 16, that gives me 28. So 1 mole of carbon monoxide has 28 grams, and he's given you 28 grams. So 28 grams of carbon monoxide means how many moles? N cross multiply, you get 1 mole. Again, I'm doing all of this extensive work for Dumbo Jumbos, right? You don't have to do this. If you know 1 mole has 28 grams and he's giving you 28 grams, that means you have 1 mole of what? You have 1 mole of carbon dioxide. Remember, carbon monoxide. Carbon monoxide is a molecule. We're talking about atoms. So let's convert it into atoms. How many atoms does it have? 1, 2. So times it by 2. N equals 1 times 2. You get 2 moles of atoms, right? In 1 mole of carbon monoxide, you have 2 moles of atoms. You have 1 mole of C and 1 mole of O. Done? And that is why our option is D. Why? Because D contains twice as much of this Avogadro's constant, right? So it does not contain 6.02 into 10 to the power 23 atoms. It contains twice the number of this. Therefore, D is the incorrect option. Incorrect, I mean, it's the option that is not correct. For us, it's the correct option, if you know what I mean, if I make sense. So, copper 2 sulfate is a soluble salt, so soluble salts are prepared through excess method. Calcium sulfate is an insoluble salt. Insoluble salts are prepared through precipitation method. We use 2 soluble salts and we mix them together. We first dissolve them in water and mix them and blah blah blah, right? Which row shows suitable reactants for preparing a pure sample of the named salt? So we have to check which reactants do we need. Well, calcium sulfate is an insoluble salt. So you need to take 2 soluble salts. Sir, how in the world is he using calcium carbonate? Is he dumb? All carbonates are insoluble except for group 1 carbonates and ammonium carbonates. So calcium carbonate is not a soluble salt. And in order to create an insoluble salt, you need to take a soluble salt of calcium and a soluble salt of sulfate. So A is incorrect. Done? Now it says, if you check B out, it says calcium sulfate. Again, insoluble salt. How do you make it? By taking 2 soluble salts. And he's mentioned aqueous calcium chloride, aqueous sodium sulfate. And yes, this is the correct option. Why? Because look at this. Calcium ions will be there and chloride ions. And you're going to get the sodium ions and the sulfate ions, right? Because they're all aqueous. Now, once you mix these 2 together, the calcium ion is going to come into contact with the sulfate ion to form calcium sulfate. And that is my beautiful, beautiful insoluble salt, pardon. So B is the correct option. And if you check C out, C is wrong because copper, my word, copper does not react with dilute sulfuric acid. Why? Because it's below hydrogen in the reactivity series. It can't displace it. Copper sulfate again, aqueous copper chloride, aqueous sodium sulfate. Dude, if you have aqueous copper chloride, so you have copper 2 plus ions and the chloride ions, and you have aqueous sodium sulfate, so you have the sodium ions and the sulfate ions. How in the world do you plan on making copper sulfate? How? Because it's a soluble salt. So every time they will come into contact with each other, they won't make a precipitate, right? They will just be soluble. So all these ions will be roaming around, no precipitate is going to form, and that is why you need to use the excess method, which I hope you all know how to do, right? So you add the acid in excess and the acid is limiting, and you add copper carbonate or copper oxide or copper hydroxide in excess and blah blah blah. The acid is never in excess. Why? Because obviously removal becomes very difficult, right? Who cares? Silver is below copper in the reactivity series. Done. Which row describes the reaction of silver? Well, dude, if it's below copper, we know silver does not react with steam, right? If it reacted with steam, every time your dad goes to the washroom to take a hot bath or take a hot shower and he's wearing his wedding ring, which is obviously mostly silver, then all the silver should react, right? No? So that's just common sense as well. But if you know your chemistry, you should be able to realize that silver, because it's below hydrogen, it's even below copper. That means it's below hydrogen, and if it's below hydrogen in the reactivity series, it will not react with water because it cannot displace the hydrogen in the water, right? So there's no reaction. Therefore, C and D are wrong. We have to choose our option from A and B. Now it says reaction with dilute hydrochloric acid. Again, silver does not react with an acid even. Why? Because it cannot displace the hydrogen in the acid. Hydrogen is above silver in the reactivity series. So in both cases, there is no reaction, and is the correct option. Moving on. Question 34 says, which compound has the most CH2 groups in one molecule? Now again, you could do this in a jiffy if your practice is good, but if your practice is not good, then you just need to draw all the molecules. So butane, but means 4 carbons, right? So meth, eth, pro, butane, because it's an alkane, you have the single bonds between carbons. It's saturated, right? Make butanoic acid, so meth, eth, prop, but, and because it's butanoic acid, we make the functional group. Then let's make butan 1-ol, so butan 1-ol, and let's also make the hydrogens, right? Let's also make butan 1-ol, meth, eth, prop, but, and because it's butan 1-ol, the OH is on the first carbon, so you can put it right here if you want. Done? And then but 1-ene, meth, eth, prop, but. Why did I make a double bond? Well, you dumbo, because obviously it's an alkene, so it must have a carbon-carbon double bond. It's unsaturated, right? Now it says CH2 groups. Look at this. CH2, CH2. This is CH3. Remember, that's not a CH2 group, right? That's a CH3 group. That's a CH3 group. So this particular butane has 2 CH2 groups. Let's look at a butanoic acid. Butanoic acid has CH3, CH2, CH2. So again, butanoic acid also has 2 CH2 groups, right? So it's also 2. So A and B can't be the correct options. Now, if you look at butan 1-ol, then it has how many CH2s? Look at this, look at this, look at this. CH2, CH2, but ting, 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 CH2 right here. You must have missed out on this. So there are 3 CH2s in this one. So butan 1-ol has 3 CH2s. And if you check but 1-ene, again, it has 2 CH2s. If I show it to you, 1A, and that's the 2A. So it has 2 CH2s, and yeah, therefore C is the correct option. Areno, this has 2. I'm going too slow on this, man. It's boring me. Ethene reacts with both hydrogen and steam. It does, and that's called the addition reaction. Which row shows the reactants? Which row about these reactions is correct? So reactant with ethene के साथ reactant कौन सा है? Hydrogen and steam. Okay, so he's saying when you're reacting it with hydrogen, it's called a substitution reaction. Oh, you dumb person, it's called an addition reaction. When you're reacting it with steam, is it called a substitution reaction? Oh, you dumb person, it's called an addition reaction. So now between A and B, the catalyst when you're reacting with steam, the catalyst is not nickel. The catalyst is acidified phosphoric acid, right? Or you could just say acidified acid. In our case, we take H3PO4 aqueous. Yeah? So it's not nickel. Nickel is used right here, and we also heat it to like 200 degrees Celsius. Right? And we go from an alkene to an alkane. So C is correct, Torino. Now, 21 says element E and F are in group 1 of the periodic table, so they both should have 1 electron in their valence shell. E has a higher melting point than F, so E should have a stronger metallic bond, and a stronger metallic bond would mean that it is above F in the reactivity series, because you need to understand that I'll give you a little bit idea of how things work, right? So let's suppose that's sodium, and let's suppose you have like potassium, right? Now sodium has how many shells? It has 1, 2, 3. It's in period 3, so it has 3 shells, right? So 1, 2, 3. And if we talk about potassium, it has how many shells? It has 4 shells. 1, 2, 3, 4, right? And the nucleus of potassium is obviously right here, and the nucleus of sodium is obviously right here. Now the metallic bond, which is the strong electrostatic forces of attraction between the lattice of positive ions and its sea of delocalized electron, will it be stronger in sodium or will it be stronger in potassium? Obviously, it will be stronger in sodium compared to potassium, and the reason for that is the distance. Sodium is a smaller atom compared to potassium, so the distance between the nucleus and the electron is going to be less. So the electrostatic force of attraction on the metallic bond per se is going to be more, right, compared to potassium, because the distance from the nucleus and the electron is huge, not so huge, it's, slightly bigger compared to sodium. That's why the electrostatic force is going to be weaker compared to sodium. Think about it like this, if I say this is you, let me just break it down. If I say this is you, you're the positive ion, and that's like your best friend, right? So that's the positive ion, and the electron is your best friend. If this is the distance, right? If this is the distance, and in the other case, that's you, and that's your friend. That's positive and that's negative. Which one would have a stronger attraction? Well, obviously, the closer this negativity is towards you, the closer, the stronger the attraction is going to be, right? So similar is the case with these atoms. So if E has a higher melting point than F, then it means that E is above F. Now it says element J and L are in group 7 of the periodic table, and J has a higher density than L, right? It's pretty simple. In group 7s, we know that the state changes from a gaseous state to a liquid and then to a solid. So down the group, right? So if J has higher density, we know solids have a higher density than liquids and gases. So if J has a higher density than L, that means that J is below L in the group 7, right? And E is above F in the group 7. So which elements have the highest atomic number in each group? Now, again, this is such a beautiful MCQ. You go to your periodic table and you know that the periodic table is arranged in increasing number of protons, right? So it goes like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So the one that is above will have a smaller atomic number compared to the one that is below in the groups, right? Let me just put the do not disturb mode on, right? So because E is above F, this will have a smaller atomic number. Atomic number means the proton number, right? And because L is above J, that means L is going to have the smaller atomic number. So which one has the higher atomic number? Obviously, F has the higher atomic number and J has the higher atomic number. So the option should be Ciarino. Done? F and J. Oh, too much explanation for this stupid MCQ. The structure of propene is shown. Which diagram represents polypropene? Remember, whenever it's all about polymerization. Your concepts at this point should be very, very clear. If they're not, watch the crash course that I've uploaded onto YouTube for 3 hours in both cases for organic chemistry, right? So that should clarify each and every concept of yours, 100%. And what I've taught there is, remember, whenever you're making an addition polymer, all the adjacent CH3s and all the adjacent atoms should be above and below the carbons which are making the double bond, right? So this CH3, you're gonna take it and you're gonna put it right here below it. So all the CH3s, everything, the hydrogens, they should be above and below the carbon-carbon double bond. They should be around these double bonds, right? So we're gonna take this CH3 and plug it right here. We're gonna just, change its face a little, because we know that in our straight chain, when we talk about addition polymerization, in our straight chain, in our main chain, we only talk about 2 carbons. And now what's going to happen is that if I just select this and bring this my bad, what am I doing? I want to duplicate this. What am I doing? Oh my god, don't kill me, please. Why isn't this moving? Okay, it's not moving. Okay, who cares? So what I'm gonna do is I'm just gonna make it 3 times, right? So that's C as CH3 and then CHH, and then I'll make it like, let's make it once, right? So this carbon-carbon double bond is gonna break and you're gonna have connect. I've emailed them a billion times to add a stroke eraser, but they aren't doing it. So what can we do? So you're gonna break the carbon-carbon double bond, and these will become the connectivity bonds, and this will be the number of monomers, right? So that's basically C bonded to C bonded to CH3. That's how it should look like. A is absolutely wrong, because when we go back into the monomers, you have to put a cut after every 2 carbons. And when you put a cut after every two carbons, you should have 3 carbons between 2 cuts. And look at this. I'll put a cut after every 2 carbons in the main chain, and here beautifully I have 3 carbons. I've put the CH3 here. He's put the CH3 right here. So B is the correct option, Reno. If we check C out, C is totally wrong. D is totally wrong, because they've not even broken the double bond, right? So yeah, that's pretty much that. I think we should do the others by tonight, maybe, yeah, because I just got tired and annoyed. But that's that, guys. Keep on spreading the word of knowledge, keep on helping each other out. I'm just doing everything I can in my power to try and save you guys, but उसको कौन बचाए जो अपने आप को खुद नहीं बचाना चाहता. And sir, why are you doing all of this? Yeah, I'm just doing it. I'm just doing it because I get bored. This is my fun time, right? So I do this to help you all, and I hope I'm helping at least some of you. And if you're getting the help that you are getting, don't try to be like, hey sir, I'm gonna do this, I'm gonna do that. Just help each other out. To be honest, I don't need anything from you all. I just need you guys to help each other out. Keep on spreading the word of knowledge. Keep on helping each other. Keep on working with each other. I've noticed something about O-levels and IGCSE students and even A-level students. They're very, very selfish. And the reason why they're selfish is because they think that if they don't tell their friends about a good teacher or a good tutor, I'm not talking about myself, but they think that if they don't if they don't tell their friends about it, then, oh my God, their paper is not going to go that good, that well, and then the threshold's going to be low. Dude, I swear to God, nobody cares, right? I swear to God, you not telling one of your friend will not change the threshold. So help each other out, help your friends out. Allah Ta'ala will help you in return. God Almighty will help you. If you do good, your good things are going to happen to you as well. So keep on helping each other out, and yeah, that's the word I like to preach. Okay, bye bye guys, ciao, see you in the next bit, bye.